So, we are on day 25 of 30 days of symmetry. Today's lesson is going to be combining kind of the physics and scripting to create this cool color tracer ball. There's another tutorial that covers a good portion of this that's already up on our YouTube channel. And what we're going to do is add in something that we haven't done up to this point, which is this emission of the kind of the velocity unit at any given time. So the speed that the object was traveling at any given time. So this sphere, as it bounces along, is going to leave behind it kind of a color trail as well as a numerical trail that says you can then kind of correlate the two or cross-reference or whatever. But yeah, you can see that, you know, as this object, this sphere, as I tossed it up in the air and released it right here, this was probably the peak of its energy. Its velocity was about here, and went all the way up here, and you could see it getting slower and slower and slower, and it was overall going to just a it didn't slow to zero because it was still moving forward in some direction, and it picked up more speed, and it almost got completely back to 12 by the time it got back down to the ground. It bounced up, and you can see it go back through the gradient of colors, and we get 8, 6, 5, 3, 1. I guess we're doing a rounding down, so this one actually goes to 0 because it dips below 1, so it's a floor rounding, a hard round down, and this ball continues to kind of bounce along. I've got its bouncing on its rigid body, its bounceability set to like 0.9, which means that it's 1 would be like perfect bounciness, which means that it retains all the energy that went into effectively all the energy that went into the collision. Yeah, we've got this this sphere. I started it in the horizon of on the moon, and I ended up adding down some gravity just to get the look I wanted. Yeah, so this is a great demonstration and of physics. It's a great demonstration of physics. It's really not all that hard to do in the code. Just a few lines of code, and I think you get a lot of enjoyment out of it, even just here in a two-dimensional interface. And I'm not in front of VR today, but we're going to be able to, if you just go interaction grabbable fixed, just like you have with any other of the tutorials, and then put a VR rig in, the preset rig, you'll be able to grab this and throw this in 3 dimensions and spin it around, and changing the parameters that we're going to go over today, you'll have a pretty cool item to play with, sort of educational toy that you can share with others. So let's take a look at the what we have here and how this is kind of constructed a little bit, and then we'll build it up from scratch. So let's see here. These things are just the lights that are in the space. This is some ball that I just put in the space to knock this other one around. There's a box. The main thing that we care about is this sphere, and then what we're going to call tracer sphere. I'll type it in here now. And tracer sphere is what's getting emitted. So this is the sample for the emitter that's emitting this tracer of colored spheres. Each one of these things that composes the tracer here is a sphere that is being cloned from this sample, and this could live here in the world. It could also live up in our library, so we don't have to kind of see behind the scenes and see what's getting emitted. But that's the template for what's going to come out of this emitter, which is called the color ball emitter, which rides along our main sphere entity. So this is our main sphere entity, and it's that when that ball falls, every time it emits one of these, which is slightly translucent. Every time it emits it, it sets its color to a very particular hue, and that hue is based and kind of scales with the velocity. It's based on and scales with the velocity. So here, where it's not very much velocity, it's blue, and by the time it gets down to the bottom and it's picking up velocity, we bring it up to about red. I scaled it to, and we're gonna be able to do this to basically go from kind of the mid-range of the hue values, which is blue, down to, which is sort of the hues run along a mapping of 0 to 360. So red to red is 0 and 360 is red. So red to red, 0 to 360. Right in the middle is blue. And then sort of this part of the spectrum here is 180 down to 0. And so we figure out a simple way to do the math that ends us up following along this. So as we pick up speed, we get more red. And you'll be able to change that if you want it to be red when it's slow and blue when it's fast. You'll be able to do the math accordingly. I just kind of like thinking about it going faster and getting hotter or something, and I associate that with going towards red. And then the other thing that we're doing, so we're emitting this ball, and it's slightly transparent, and it's getting colored. And then we're also emitting this this number object, which you'll notice as I rotate it always kind of faces the camera. So it's doing what's called look at. It's constantly looking at me. And this is actually just, this object right here is actually just a simple label from the UI game selection of the toys, or the tools, excuse me. The UI game section, there's a thing called label, and we'll be using that, which then is the number label. And we kind of set its position, and we get the overall, we get the velocity sort of immortalized in time here, however fast you were going. You can imagine what it might look like if you had an actual vehicle leaving these tracers behind on the road. So let's build this from scratch, and you can see it there bouncing off of some uneven terrain. Let's build this one from scratch. And oh, the last thing I didn't even mention, but it's there's just like a simple texture on this sphere that makes it kind of look, it's like some rusted metal or something, just to kind of give it another kind of a marbled metallic look or something. Didn't spend much time on that at all. Didn't spend much time painting the terrain. Just a quick bloop, bloop, bloop. Just to sort of set up a simple little scene. But this is a fun one, and let's dive right in. I keep wanting to kind of mess around with it. Yeah, I've like adjusted the terrain, that's why it's a little funny. But there you go. We're gonna go to new, and I'm gonna do this in just a basic terrain space. Nothing fancy. The first thing we're gonna do is just start off with a sphere, and you can do this with a regular sphere entity. You could do this with any object that has a rigid body, frankly. You know, so you could use even an object from Google Poly or whatever that you would add a rigid body to. So that's absolutely an option. You could also use the actor movable ball, right? And you'll recall if we press play and use the W, A, S, and D keys, you'll see me pressing them here. You can move it around just using your controllers. And if you're going to move this around, if you're going to move any object around in VR, so if you wanted to like pick this ball up that we're going to create, just a normal sphere, you're just going to press interactions, grabbable, fixed on it. And then you can grab it, or loose, but I would recommend fixed, and then you can grab it with your lasers and throw it up in the air and bounce it around. So today we're just going to use a regular sphere entity from entities, not the movable ball from actors. So we'll go to sphere. I'm actually going to give it a standard size. So let's see what's our size here. Yeah, we'll just it doesn't actually really matter, but I'm going to make it 0.5 radius so that it's actually like a 1 meter in diameter. Let physics bounce it up so that it starts evenly. You saw that I moved it here, and then when I press play, it bounces up. You see that? I don't want that effect, so what I'm going to do is let physics take control, and then I'm going to select it and hit Control-T to commit a transform change, which like puts my sphere flat on the ground so that when I stop and play it again, it's not fighting the terrain physically. So I get it nice, I get it rested. And then because I made my radius bigger, it sort of ended up sticking it underground in stop time. But since the physics engine moved it during playtime, and when I press stop, it wants to go back underground, what I did was I just committed that transform change during playtime or pause time so that it now defaults to this position, the stop time position, the pre-playtime position. Demonstrate that one more time. For beginners, this can kind of trip you up. If I place it here, if it's here, and I press play, it bounces up, and I press stop, it goes back. And if I don't want that to happen, what I do is I press play while we're in playtime, and I'll select the object and hit Control-T. Transform change committed. And that's also under edit. Under edit, excuse me, under object, under tool, commit transform change. View, playback. Oh, I have to select it. Sorry, that's what I was looking for. Once it's selected, it is under edit, and it should be right there under object. I think. Is it? Excuse me. It's only when you're selected on the object and you're in playtime. There you go. That's the only time it actually makes sense and applies. So it's right there. That's why I wasn't finding it. So if your object is selected and you're in playtime, you'll see that it is in fact under edit. Anyway, Control-T, commit transform changes. So if I want the ball to stay there, I can hit Control-T, and now when I stop, it'll stay there. Okay, great. So let's begin. So I've got this object, and this object obviously has a rigid body, as all of the entities do, which means it's ready to it's going to be physical. It's going to have physics and roll and bounce and all that. We'll play around with the bounciness later, but this is what we need to start with. What we're going to do is basically leave a tracer that looks like this ball, but it doesn't need to be this ball. It needs to kind of be like a shell of this ball. So what we're going to actually do is create that tracer now, and what I'm going to do is just hold down Alt and drag off this a copy. And we'll go ahead and name these so that we can keep track of them. The first one we're just going to call ball, I think. And then the second one we're going to call tracer. So on tracer, we're going to do a few things. First of all, it doesn't need to be trigger activating. And second of all, it's not going to have a rigid body. It doesn't need one. So we're going to remove that attribute entirely. It's just going to be a ghostly, semi-transparent image up in the space. And so what we're going to do is remove that attribute entirely. The next thing that we're going to do is actually give it a new material. And instead of this default material, we're going to make a new material. So we're going to hit new and standard material. It'll default to a random color. What we want to do is click on standard material, and we're going to make some adjustments here so we can get that transparency and the color changing available to it. So we're gonna pin this tab right here, pin the tab of standard material, because we're going to be affecting this material a few times. So I want to make sure that it stays up and open. So standard material. Let's take a look. First of all, I want its diffuse color to come from. I want its diffuse color to come from the object level color. So not the material level color, because this material is going to be shared across all of the copies. And if I make a change, for example, if I clone another one off of this and I make a change to this material, oh, excuse me. If if I make a, anyway, ignore what I just said. Basically, it will get a totally new material, but you want to be able to access the underlying object color, which is this. So there's two colors that add together. There's the standard color, the material color under diffuse, and the object color. And the way that you can think of them is they add together. So black won't contribute any color. So if I make the material color black, then I can go entirely on the object color, which is here. But that only works if I go to the diffuse color source and make it material plus object color. So if I go to material plus object color and I make I can basically negate what the material's color is going to be if I just set it to black. And then the color of my object is now whatever this object color is. And we can access this parameter through like tracer or whatever this object dot color. So it'll be the dot color property, and we don't have to chase it down and get the material. We could, but I'm just showing you an easier way. So we're going to basically do this, right? We're going to go through the hue and change the hue like this in our tracer ball. So changing the dot color property across this hue value is what we're going to be toggling. And instead of like going and getting the material and diving into its diffuse property, we're just going to change object.color. So it's kind of a shortcut route to color. Cool. So let's default our color to pure white on our object color. And again, standard material. This is our new material that we've made. Make its color, make the color black. We're on diffuse, color black, material plus object color needs to be here, right? Material plus object color, not material. Material plus object color, material's black, negate it. We're going to be changing our object.color there. Okay, cool. Translucency, you've got some options, and this is sort of like you can do it to your own taste. And there's three different types of sort of translucent. There's primarily three. These are the three that I use most often: is an opaque, an alpha blended, and an additive. And they each kind of have different, slightly different effects. We're going to actually use additive today, which means that these objects will sort of be bright when they stack up on each other. They'll kind of create an overall brightness. They like add up on one another, like layers in Photoshop. So we'll just remove these, and we'll do additive. So the material that's on our tracer we just did the diffuse. The translucency is you can tinker with the opacity, how much you want. Let's work with like 0.3 for now. So blend mode's additive, and we're not going to change any of the other properties. So this is pretty much good to go. So as this ball rolls along, what we're going to do is have it emit these sort of ghost replicas, right? Okay. So let's put this ball over here for the time being, and this will be kind of our specimen. This is just going to act as a sample for our emitter. So let's get the emitter rolling right now. So what we're going to do is take an emitter and just click it anywhere, because we're going to end up sticking it into where we want it. So node emitter needs to child. Grab the words of node emitter. It needs to child to ball. So it needs to be a child of ball, so that wherever this ball goes, the node emitter goes. And right now it's emitting that default object, and we want to make now this node emitter not emit that, but emit this thing. So now that our node emitter is is a child of the ball, we want to center it. It needs to be in the dead center of our sphere. And then let's just zero out its rotation. I'm double clicking the roller just to get zeros. You could also set them here. And the next thing we want to do on the node emitter, and let's go ahead and pin our node emitter as well, because we're going to workshop it. So now we can kind of go, and if we want to change our additive value, we've got it right here, because we're kind of workshopping that material still. And then our node emitter, we can kind of come back to it as well. So that pinning is really helpful for workflow. So let's go to the node emitters. We just changed this transform. We zeroed out its position and rotation, which means it lives in the dead center of the sphere. And then we're going to select it at the top here to work on its properties. And through its set of properties here, we'll be able to get that tracer effect. So first off, we want to do, we're gonna pick we need to change. We need this sphere to be our sample. So we can, since it's in the world, we can actually just pick it. You can either pick it here, and you can see that it's actually highlighting over here. While I highlight it here, it's highlighted there. So you could pick it in the hierarchy or pick it in the space. So I'm gonna pick it in the space, and let's take one more look. So what do we expect is going to happen? We're going to be able to emit basically 20. We'll be able to live in the maximum that'll be like trailing behind this the ball. Our continuous is this constant pulse. We'll pin this as well because this is another thing. We may be changing the frequency. And I'm going to show you two ways. So we can expect that one ball is going to get emitted once per second. One tracer will get emitted per second because right now our constant pulse is a frequency of 1. So one pulse per second to emit this sphere and to emit the tracer. The sample set is tracer. This we're going to play with in 1 second. This is not how we want it set, but I want to show you what this looks like right now. And let's go ahead and press play. And when we move this sphere, you'll see that every second we get a pulse and we are emitting this object, which is cool. One thing we want to do is speed that up for sure. So let's go ahead and do that. Let's do, and then the second thing, so we'll speed it up. And the second thing I want to show is that this tracer, if I change its color, if I change any one of these colors, the colors of any of these emitted objects, I'm also changing the every other one of them, and that's because what they are what are called shared copies, which is a full instance kind of it's a full copy of this object, which means, and you've learned about that in under Intro to Basics in, let's see, which one is it? I think it's just drawing basics. No, it's cloning. In copying objects, you've learned kind of how these different properties work. So the main thing you want to pay attention to, and this will happen all the time, you just kind of need to remember as you make a node emitter and you're like, why are all those things like acting the same? It's almost always because of this. You want to change the way that it clones them from a shared copy to a copy. So the downside of doing it this way, the upside of doing it, making a copy, is that each one of these can get its color changed, so that we can get that color changing rainbow trail, because we can change the color on each one of them without it changing the rest of them. The downside is it won't be a problem for us, but since we're using like a primitive thing, but the downside is that it takes a lot more memory. Each one of these objects has to commit an entirely new chunk of memory per object. It doesn't just share. That's why it's called a shared copy, because they share. They just like reference the color, and it saves a lot of space. So if you're actually trying to emit a bunch of stuff and you want to save space, shared copy is your ticket. But it'll have the downside that you can't. You'll end up like changing all the things. All of the properties kind of track each other, all except for the transform. They can obviously live in different positions and stuff. Okay, so we want this to be full copy. So when we press play, okay, and we get a handful of these out, one every second, you'll notice now that if I change tracer, I only change tracer. And if you ever want to be able to select these emitted objects under, I'm trying to remember where we've put this recently. We recently reorganized this. I think it's under View, Tool, Playback, under Playback, Object. Select Playtime Generated Objects. Select. Curious why I'm not finding this. Sorry about that. Select all copies, select all. Oh, there it is. It's not select, it's lock, excuse me. Lock playtime generated objects. Let me do this again here. These playtime generated objects are anything that are come out of a script called clone, a script that runs clone as copy or anything like that, which we've done on some of the like fractal and lightning tutorials that Amadeo did last weekend. Or these, see, I can't select those. I can select that object and that object because they're stop time generated objects. It's because I've got lock playtime generated objects selected. This is what it is. I was looking for select playtime generated objects. So we're going to unlock those if you were to want to select them, which technically if I select this one, it's gone out of, I need a fresh one here. Just to demonstrate that I can select it, and if I were to change it, there we go. I can change its color, right? So I can change the color of each one of these without changing all of them, and that's the result of emitting under the emitter under the property clone as copy. Allows us to select those. I'm actually going to go back to this and relock the playtime generated objects. I just wanted to demonstrate to you that what I was able to do by selecting one of those cloned objects, we're now going to be able to do that by script. So as we emit them, we can color them. Cool. So we're emitting, and we're emitting too slowly. So let's think about speeding that up. Let's take a look. So on the node emitter here, it was our constant pulse, which it's our constant pulse which will drive how frequently those happen. So let's say we do 4 per second. So every quarter of a second. So that leaves a little bit of a trail. So let's try constant pulse like 8. There you go. You can see that if it goes faster, the trail gets sparser. And if we go slower, it starts to get more dense, right? Because it's covering less ground per unit time, and then they start to overlap more. So there's no right way to do this. I'm going to show you the second way that we might do this, but there's it's really kind of up to you on how you want to how you want this to look. So if you emit based on time, that's your effect. That there's that it'll space out when it moves fast and be denser as it goes slow. A different way to emit, which is important to know about, is by the moving property. And so for the time being, we're going to turn off the constant pulse. We'll say it's active false, which means that the pulse won't do anything. And what we're going to do instead, for the time being, instead of running from the pulse, is use the moving to emit. So the emit rate is how many units, or how many times do you want to emit per meter, per unit, and that's a total meter traveled. So a calculated meter in any direction when this travels. So let's take a look at what that looks like. So if we say 1 per meter, and we move this ball, you can see that it almost evenly lines up because this ball is exactly 1 meter. This ball is exactly 1 meter in diameter, right? So you get this kind of perfectness out of it, kind of a perfect trace behind. So what happens here is that if this goes faster or slower, it doesn't matter. It'll always look equally dense. See? Oh shoot, sorry. Rotate it off to the distance. So just, you can now see that there are two different types of ultimately like effects. So this one might be what you're looking for, kind of a tracer. And let's actually let's densify this. Let's make it overlap. So what if we said 4 per meter? It's going to be consistent. Did I change that? Oh, sorry, that's under the constant pulse. That was the wrong thing to press. I need to be emit rate down here under moving should be 4 per meter. So now you get this much denser trail behind it, and it almost blurs together. And since additive kind of works in a way, it like they kind of add up on each other and sort of make it a bit brighter. You can see now that that's cool. It actually kind of looks like, you know, this effect. At least it's a consistent trail. I can use color as opposed to density to kind of indicate my velocity. Whereas in that first one, the density already works as a proxy for describing the velocity, right? Oh, it was moving really fast, so they became sparser, and that's fine too. That might be one way you want to do it, but we're going to proceed the tutorial with using the moving rate, and we'll go ahead and continue on with our constant pulse set to active false, so turned off, and then emit rate at 4 here. Now you notice that the tail was a little small. Oops, I accidentally grabbed the node emitter itself. The tail's a little small, like it won't even make a full parabola for me, and that's because there's only 20 that can be simultaneous. So the max simultaneous that can be out here is 20, and that's so that you don't end up with infinity of these things produced. So it deletes out the last ones, right? So let's set that higher and see if we can get a bigger tail here. Let's set it all the way up to 100. I know the computer can easily handle it, and we'll throw it up, and there we go. Cool. So now I can, you know, I'm gonna get a couple parabolas with that. Great. So it's absolutely working. I'm gonna select our original tracer and reset its color to pure white. And one more thing I want to do on this note, this ball, just so I can have more demonstrational effect, is I'm gonna set this up to 0.95. That's the bounciness. I'll set the bounciness to 0.95 so that when I throw it up, it'll keep bouncing and kind of give me more parabola for my money. There we go. Good. Okay, cool. So now comes the beginning of the magic. We've got this guy emitting this guy, this sort of ghostly shell. Now let's change its color. So the way that we're going to do that is through basically we need to change the color of the exact tracer ball, you know, at each point. So as it gets emitted, we don't want it to be white and then suddenly change colors. We want to like intercept it at that the exact moment that it gets emitted. And fortunately, we have an event on our node emitter. There's a lot of properties on this node emitter, and you'll get accustomed to kind of managing your way through it, because there's a lot of you can do a ton with these emitters, which is awesome. All the way down is going to be events at the very bottom, and on these events you've got, like the other ones we've been using, on init that happens at the very beginning, tick, which happens every frame, move when the node emitter is actually moved and updated in its when its transform data updates, and this one that's special to the emitter, which is on emit, which is what we're going to use. So let's click on emit, and we'll get the Lua scripting window, and it'll pop up, and this is the function that runs every single time it emits. And as you recall, it's going to emit 4 times per meter traveled. And so what we are going to do is we need to get the velocity of the ball, which is our parent node. We need to get that velocity, and then we need to color the object that we're emitting, which is in our function here. It's actually passed in as this little thing called obj. So obj is the node that is set as sample. So whatever's set as sample, which is in our case is the tracer. So obj in this context is going to reference tracer. Self, of course, will reference the node emitter itself. Self get parent is going to represent this ball, and the self get parent get rigid body is going to represent the physics representation of the ball that's traveling along, that's bouncing along. And so basically, we're going to write code that's going to be get the parent's rigid body, get its linear velocity, and particularly the length, the magnitude of that vector of my velocity, and then take that number and now take the object that I'm emitting and scale the color of that. So that's what we're going to do. The first thing we're going to do is get parent velocity. So the way that we do that is self colon get parent node. That returns the ball, and that's lowercase g, uppercase p, uppercase n. Self get parent node colon get capital R, capital B rigid body, colon get linear velocity, open close parentheses. That'll return the three-dimensional vector of the velocity vector. So, you know, if it's traveling straight up, that's going to be a lot of that's going to be a vector, three-dimensional vector that's like really high in the y dimension. Let's actually pause right here because I want to print this out for you, and take a look. I want you to see what you're working with here, and then we'll turn this into a string by typing toString with a lowercase t and a lowercase s, and we will turn a string. We will stringify this three-dimensional vector. The parent node's rigid body linear velocity. We're going to turn it into a string and then print it, and that's going to be 4 times per meter. And we should see the little printout down here, and we'll see this vector. So you can now see this vector, and if I catch it right at the top, you'll see that the y, there's not that much in the x or the z, but there's a lot going on in the y direction because I'm throwing it basically straight up, right? And then when it comes down, a little bit of x, no z, and -8 in the y, and which is to be expected too, that one of these is going to have a value and one of them isn't, because you're only moving two. This square on the transform widget only lets you move move this in 2 dimensions at once. So if I were to switch that and press play, if I were to switch to this other one, you can see now that I'm moving it into Z, but the X is not changing at all. Anyway, this is you want to kind of, it's nice to print it out, get yourself a sense of what the velocity vector looks like. The velocity is a 3-dimensional value. That the actual velocity vector is a 3-dimensional value, and we certainly could print this out to if that's the data we're interested in seeing on the screen at some point. But we certainly can't use it to scale our hue. Our hue is actually, you know, going from red at 0 to 360 at red again, kind of around the circle of color values around the color wheel. That's a 1-dimensional value, so we can't take our 3-dimensional vector and do a 1-dimensional value. So we need to know a different thing. We don't need to know the velocity vector. We need to know the actual speed of the ball at any given point. So we need what's called the magnitude of that 3-dimensional vector, otherwise known as speed. And the way that we do that is we'll go back to the code. We're going to right-click on node emitter and hit edit code. The way that we do that is just one more piece of the function at the very end of self get parent node get rigid body. So self get parent node get the rigid body of the parent node, get linear velocity. One more thing, colon, any three-dimensional vector has a function called length that'll return the magnitude of that vector. And so this, for a velocity vector, is actually speed. So we're going to print that. And now we've got this nice number, one-dimensional number, that slows down, and then eventually this will sort of go to 0, right? So cruising along, and it's pretty bouncy, so. There you go. So that's the number we want to use. And right now we're not going to print this whole floating point long thing, but when we get there, we'll be trimming that down. So let's get a hold of that number, and let's change the color of the tracer that we're emitting. So let's go back to the code, and we can just remark this for the time being with the 2 hyphens. We're going to copy this piece of it out. This is the one that we care about, because we may want to come back and look at it, or if we do other things, we may want to like debug or kind of test if everything's working all right. So we'll leave that there. So what we want to do is use this to be our hue value. So what we want to say is the tracer that's coming out that gets emitted, which is obj. We're going to say obj.color equals, and now we need to pass in a color value. And the way that we have to do that is either with RGBA or with HSB. And so HSB is the function we can use to give us, we need to pass in 3 values, and that's a 0 to 360, that's then a 1, then a 0 to 1, then a 1 to infinity. So what is HSB? Hue, saturation, brightness. So saturation, we're going to say be fully saturated, so that's 1, so that's after the comma. Then the second one is brightness, and brightness will also allow it to be just 1. That's kind of full brightness, and anything above 1 is like glowing. So we could go above that. We could say 2. We could go up to infinity, but we're just going to say 1 for now. So the thing that we're really trying to adjust under HSB, which takes in 3 values, is we're changing the hue value. So right now, you saw us print this. We're going to pass in self, get parent node, get rigid body, get linear velocity length, and that is that speed value. And when we tossed it up in the air, I noticed and I remembered it, and you'll see that I generally am keeping it within the range of 10 meters a second, which prints out as 10, right? So it's 10 speed units, which is meters per second. So 10 is what I'm getting back. And if my value is 0 to 360 in here, which is red all the way back to red, and I'm just giving it a 0 to 10, I'm not going to get that far in the red dimension, but let's just make sure that our code is working now, and then we'll come back and tinker with this to get our nice color ramping. Let's see if we've done this correctly. No errors. Yeah, and you can see that we're sort of just gently moving through the oranges. And if this thing comes to a stop, my assumption is we will get ourselves to kind of a harder red. Yeah, it's sort of redder in here where it's going slower. And at the peak, too, when it kind of slows down and gravity has neutralized it and gravity isn't winning, you're getting you're getting a bit redder. But that means we're going down to 0, so it's sort of going from like let's say we're at 10 meters per second here to 1 up there. We're not going that far. We're going from 10, which is slightly above 0, but we need to go from like 360 to 0. So we need to actually scale this value. Okay, so let's do that. Edit code. Editing code again on the node emitter on its on emit, and what we need to do is make this value be a bit more scaled. So let's say we go from 0 to 10 in the actual like speed things. We want that to map to 360. So then let's just multiply this by 36. Let's see what we get. So that means that when it is 10, when this value is 10, when we're at 10 meters a second, we'll be at a full 360 here. So let's see what that looks like. That's pretty cool. It's actually, we're going kind of bluish, greenish, slowly going to yellow. Yellow. And when this thing is like 1, when this thing goes down to like 0, total 0, it's difficult to see, but there would be like one little kind of reddish orange one in there. But yeah, so this is cool. And you pretty much can just about take a victory lap at this point. But I have to say that when I did this, I started to really want I wanted this to be more like red when it's fast and blue when it's slow. So what that means is that I want to go from like blue being 0 and red being 0 and red being like 10. So right now we are at approaching, and we can actually print this out just to see. This might be helpful. Let's do this one more time and take a look at this so I can actually sort of show you the way I'm thinking about this. So I'm throwing this up, and I'm actually not getting quite to 10. I'm actually staying within like 6. It looked like was like the highest there when I threw it in the air. Let's take another look. I can throw it a little harder, and I got it up over 7. Let's try it again. That's 20, and I'm throwing it too hard. That's more around the 10 range, and that's fine actually. I am indeed getting to up into the reds, and when I don't quite get to the reds, I'm in this purple zone. So in general, I like where it is now. Basically, that when I get to 10, I hit red. So let's take a look at this code. When this gets to 10 meters a second, this goes to times 36. That takes us to 360. But when this is at 0, I'm all the way back down past blue over into the warm other part of the spectrum. So I just need to take this value, and I need to basically, this needs to be start at 180. So I will think about this just starting at 180, and it needs to be half as aggressive. So if I add 180, that means when this whole value is 0, then it'll start in blue at 180, and then I want this. I want when it gets to 10, I want this value to equal 180 so that it adds to 180 and it gets to 360, which is red. So I want this to actually be half this value, which is 18. So we're basically squishing ourselves into the top half of the spectrum, and let's just take a look just for your own edification. If we come and affect the color on this, let me use the color components attribute just to show this out. We'll make the saturation 1, and then take a look here. 0, 180, which is like blue. You could actually, even if you really wanted to, consider 240, like dark blue. You know, anywhere along here, you're hitting blue, and red is again at 360. So we could find ourselves, basically what we're doing, we say when it's 0, add 180, we're going to end up about here, and then when it's 18 times 10, which is 180, add 180, you're going to end up at 360. So we're going to end up in this chunk of we're ramping through this. So let's watch ourselves kind of ramp through that. I'll set our little educational ball over there. And this is exactly what we intended to see here. As we go, when we get up to the peak and our velocity gets slower, we're down in the blue, and we're speeding up to the reds. And this is cool. I give you permission to take a victory lap at this point, but I want that look. I want to actually move through. I want to move through this part of the spectrum. I want to move through here. Like, I like the blue, green, yellow, orange, red. Like, for some reason, this just has much more dynamism and color. I want to go from And it also is this nice sort of pivot from the cool colors to the warm colors. And so anyway, I want to move from 180 when I'm going 0, and I want to be at 0 when I'm going 10. So how are we going to do that? Well, the way to do that is, excuse me here, is subtract this value from, from ourselves. So basically we want this to invert. So we want, when this is when the value is 10 here, when we're at full velocity, I want this to be red, which is 0. So I want this to be 10 times 18, but I want it to be, this whole thing to be negative. And so I can actually just call this negative 18. And when this is 10, this will be negative 180, which will subtract from 180, which will make this 0, which will make it red. And when this is 0, this will be 0, and then the total value will be 180, which is blue. And then half that, when this is 5, will end up halfway in between, subtracting half as much from 180. Cool? For some of you, I know that seems dead simple and straightforward, but I'm sure for a lot of people that's kind of instructional. And so now, by just flipping that sign, I end up with this nice system where I'm getting, and I'm still fairly yellow. I mean, I could get ourselves like red faster. So I think if I want to be red, I want to subtract more or scale by more. So I could either I could make this a bigger number. I think if I go like 24, I'll end up with more red in my system. I think, yeah, and you can see a bit more. Is that right? Subtracting. Another way would be to drop this down to like 140. So I can be, but that'll be setting up this is setting up your upper bound basically. But anyway, the rest of this is really sort of do this, to your sort of taste, sort of as to what, because you may get in here and be throwing this thing faster than I'm moving it. And the other thing is that we do kind of max out at the red values, but if you were expecting that you're not going to be going too much more over red, then this would work just fine. So cool. So we've got this. Now we're going to figure out the number system. And I'm pretty sure that we should be able to clone, for example, if I wanted to make clones of these. They should all work and run different things. And you can change, gravity to sort of get you this kind of a deal. Cool. But I'm going to just start with our 1. That's our show sphere. I'll leave it there. It's a nice background. I'll get rid of these. I'll change gravity back. 0 out the 1 and the X. And I'm going to bring this back to 180. We'll go to like 175. That's not bad. So how will we put a velocity, what do you call it, a speedometer on this? Let's check that out. So we have this nice tool under here under UI game called label, and you can click it on this object, and it populates this this node with some code attached to it called label. And you can drill in and take a look at the code and what it's doing. And we're actually going to use one of these functions on it inherently. But let's do a little stylizing first. The first thing we're going to do is get our style going, and then we're going to figure out how to change its value based on the velocity, and then we're finally going to set up another node emitter to emit this label along the way. Let's get something a little thicker than Arial. I guess we could go Arial black, that would be fine, but not a huge fan of Arial, so I'm going to reach for Roboto, and I'll do Roboto black, and I'm going to change the size here to be kind of a nicer size. You can add a little extrusion depth if you want, but kind of give it some volume. I'd probably go without any. That's fine. And I'm actually just going to call it speed. This will sort of be the thing that it calls itself by default. And you'll see now that this label comes with us. It follows the ball. And if I rotate around it, it also has that look at. It continually looks at the camera, so which is really nice. And if you go into VR, it should also look at you, not the default camera. It detects the active viewport, and if the active viewport is the HMD, it should look at you as well. So this is cool. It looks at us. We get a nice parabola, and we've got this label. This is working out well. Let's figure out how we're going to change the text. You'll actually could do this two ways. One would be to get this object, get its text shape, dot text, and change this value, and that works just fine. This label has this little function that comes packaged on it called set text, and all you have to do is pass it any text, and you see that it's actually literally doing what I just said. It goes self get mesh model get shape.text equals the text that we pass in. So we're gonna have fun by just calling the text function. So what are we actually setting up here? So as this ball moves, it needs to, when the ball moves, we're getting a new velocity update. So this rigid body, if the ball moves, this rigid body is getting a new velocity value. That velocity value can get passed over to this, needs to go over and get passed over to this label value. So let's take a look at that. How do we set that up? Well, just like the node emitter had that event, which is on emit, our ball has, and almost everything does, a on move event. So let's use the ball's on move event, because if it doesn't move, there's no reason to update the data. We don't need to do it every tick, every frame, because if the ball's just sitting there, we don't need to run this code, 90 or more frames per second. So just when it moves, which is great. So we have this function called on move. We're going to say on move. And on move, when we move the ball, we want to get, so the function's happening here on the ball. We want to get the label and set it to our rigid body's velocity. So let's basically, and by the way, the label has that function called set text. So we're gonna call set text on the label. Lowercase s, uppercase text. So let's go back to edit code on the ball. So when we move, what we need to do is get a hold of our label and set text. So we're going to say label equals self colon find node by name. And then we're going to say label that finds this, which returns label. So then now we can run label colon set text, which is that function, and then in the set text we're going to pass in a value, and that value is going to be our self colon get rigid body open close parentheses colon get capital linear velocity open close parentheses, and that gives us that three-dimensional vector, but we also want to get the length, colon, get length. And if you press play right now, it may run, but you're going to want to set this to a string. So you need to do toString, and that's lowercase t, lowercase s, to string, to make this a string value, to make this something that the thing that the text value wants a string. So you need to make sure that this value coming in is specifically set to be a string. So self, get rigid body, get linear velocity, get length, that gets us that speed value that we are setting the color with. And now we're going to set that text, so it should update. And let's take a look. Oops. Get length. I did that wrong. There is no such thing as get length. It's just length, and it's lowercase l. Excuse me. I was getting rigid bodies, getting linear velocities, colon length. Got carried away with the gets. So let's press play. So it's, yeah, just lowercase l, colon length, open close parenthesis. Cool. There it is, constantly updating. But my gosh, look at all this. What is this? Like 12 decimals after the numerals after the decimal point. We don't want that. So what we are going to do is one more thing in here. Before we string this thing, what we're going to do is let's wrap this in parentheses, because we're going to run one more little function on it, which is called math.floor, and that's going to be it's going to round that down to the nearest integer, or not to the nearest, but if it's I think it's a hard round beneath an integer. So let's take a look at what that does. That's much nicer value to work with, and we're going to work with that. So this is quite nice. We've got, you can see, you can actually then really coordinate the colors. You sort of understand that as we get up to 9 and 10, we really hit red, and we kind of max out there. Pretty cool, pretty cool. So now we just need to emit this node. We need to emit this node at the moment that this is getting updated, and we go to hit emit. It's going to reach over to that value. It's going to reach over to the label's value, and it's just going to immortalize that value where it's at. So if it's 10, it'll be 10, and it'll stay 10. So that's a nice kind of side effect of how we've set this up. So what we need to do is set up a new emitter, and we can actually just, if we want, we could kind of copy our own, the one that's here, but we can just we'll make a fresh one here. We're going to say emitter, node emitter. Just click on the ball, and then you're going to drag by the words under the ball. Let's make sure that we name these just for sake. I'll call this tracer node emitter. That'll keep that organized, and then the new node emitter is called we'll just call speed node emitter. Okay. So on the speed node emitter, we need to change some things. First of all, let's center it on our parent as. Now I'm just double clicking these scrollers to get zeros, and then on speed, I'm going to sorry, on the node emitter, I'm going to change some properties. We don't know if 20 is too few or too many. We'll just leave it there for now. Now we get to ask the question, do we want to emit on moving or on continuous? Like, do we want to, how quickly do we want to update? Yeah, you can imagine that obviously the overlapping is like, makes sense for creating this tracer effect, but that's a lot of numbers. I'm not sure we want that. So what were we doing on tracer, by the way? We're emitting 4 units per meter. We could just try 1 per meter, maybe. So let's do moving, and we'll do emit rate just 1 per meter. Maybe we'll kick that up to 2 if we want. But we need to turn off this pulse. So let's do no. Or we can either set this to false, or we can actually just set it or create and the node emitter make it none. So here on the speed node emitter, our constant pulse, we just set it to inactive, and we're going to emit at each meter, or at once per meter of movement. And the sample needs to be, and this is key, pick the label. So that label that's constantly changing is the thing that's going to be emitted each meter. And don't worry, it's not that label that's constantly updating. The label itself isn't updating. It's getting updated by the ball. On the ball's move event, the ball is the one reaching over and telling the label what to be. So when we copy this label, the label doesn't continually update based on its parent's rigid body. So the way that we've structured this code is that the ball tells the label what to be. This goes and clones it and just sort of samples it, but it doesn't. This will be static once it emits, and so we'll watch that now. So we're going to clone this. We're going to clone the label, and we're not going to clone it as a shared copy, because then the numbers will all be the same, and when it gets updated and there's a new number on it, it'll go and change all the old ones. So we're going to make that a full copy, and I think we should be ready to be emitting these numbers, and I can see them in there, but I'm going to kind of bounce this to the side. And that actually looks kind of awesome, the way that it kind of gets swallowed in the additive effect there. It's pretty cool. I mean, the numbers are in the thing. I like that. But what if I wanted to make them just like stick out above and kind of be generally kind of more like, it won't work if it's fully, if I wanted to set the position to be kind of always vertical, that'll at least give me a better chance of this sort of being outside of the tracer. So I'm going to make sure that these things that get emitted go up about a meter or so. And so when our speed node emitter emits, I want it to set the object that it emits to be a little bit up. So we're going to do another on emit event, but this one's going to be on the speed emitter. And so we're going to select its properties, come all the way down to events, expand them, and create an on emit event. And so here, I'm going to create an event called, so it's on emit, and this is, we're going to set speed text a bit higher than tracer. So what we need to do is, the speed text is, remember, obj in our on emit is the thing that we're emitting, so we'll say obj, and we're going to set the world position to a value. And so in this vector, we need to set it to a value. Well, when an object gets emitted, first of all, whatever it considers the object center is, gets aligned to the emitter's center. So I can say I want to set it to the position of the emitter plus some value in the y amount. So emitter plus some value in the y. So the emitter is self. So we're setting the object that's getting emitted, but we're going to base it off of self, which is the node emitter. So we're going to say self :get world position. That's the current position of the node emitter, and then we're going to add a vector 3. So we'll type vector 3, and then in the vector, we're going to do 0 in the x, 0 in the z, and for y, you know our sphere is radius was 0.5, so even if this goes up a meter, we should be, that should help. And let's take a look. Certainly works. When it's going sideways, you start to get a little bit out of it, and that's certainly helpful. You know, I haven't fine-tuned the design on this, and so you could do a lot of other things, but you know, the tutorial is meant to be just kind of an initial glance, and really kind of getting you to think about what you can do on emit, and making on emit be really useful. Obviously, the vector, this offset vector that you're creating here could be, you could do something really dynamic where it kind of always is off normal to the kind of tangent, right? So it could be normal from kind of the surface of this curve. That would be another thing that would take a little bit of vector math, and I'm sure with what you've got here, you could do a little exploration and a little learning on how you might set this thing kind of constantly always out from the position, which might not have the desired effect. You could make this number glow, and it would even shine through these tracers. But something also, to be honest, like this kind of looks awesome. Some of this, like these numbers just getting like that additive effect kind of happening over them like that. So that's pretty cool. Yeah, so there you go. Play around with, you could emit these a lot more. You could emit these by time. You could be emitting these numbers by more. You could do more per unit time. So you could get this. Let's get this going. You could do more per units. Per the moving. And I could crank these up to. You'd end up with a lot more numbers. It gets illegible clearly. You could crank up the number of simultaneous on both, so you'd end up with a longer tail. And then you can you could bounce these into walls, change the color ramp. You could add some logic that if it exceeds 10 to start another number value. You could change the brightness in the HSB, so brightness could also scale along this, so that it really glows when it's red. So the glow could really kick in here, so you'd know that it was extra. Was going with extra speed. The last thing, which is kind of cool, is, and this takes you to your high school algebra / probably calculus rate of change, is right now we're doing the three-dimensional velocity vector, and it's cool that these objects they keep their internal record of their velocity if you move them in stop time, so they'll kind of move along. What you could do is, right now we're working with 3 dimensions, but you could say I only want the velocity in the upward direction, which is really interesting, which means it'll, because you see right here, this should be 0. Well, sorry, change in y over change in time would be, as this comes to the peak, it stops changing anything in the change in y actually goes to 0, right? The slope of this actually goes to 0. And this shows us that it's still, the velocity is 2, because it's taking into consideration the change in this dimension being the x dimension. So there's still a change in x over change in time here, which gives us this 2 value. But if I change this to visualize the change in just the change in y over change in time, I'm going to get a different color, and I'm going to get a different number, which is pretty cool. And so that would require basically on your tracer emitter to not just get the length of our 3-dimensional vector. You would just get the dot y value of this 3-dimensional vector, and that is how you would get that that change. I think I should be able to do it. We'll go ahead and see if we can print it first. The first thing to pay attention to is that we are get linear velocity. If you go get linear velocity dot y, as opposed to length. And it'll be printing here. It starts at 0, and right about here it goes back to 0. So if I set the color to this exact thing, .y, we should see a very similar color ramp, except that we can do the same for this number instead of for the label if we edit the code. Oops, it's on the ball. On the on-move event of the ball, I'm getting the linear velocity. If I change it from length to .y, I'm now seeing the linear velocity in the y direction, which is cool because now we're seeing negative, because which is interesting, right? Because length actually gets the overall positive. It's positive in all directions. It's either 0 or positive, but now we're starting to dip into these negative numbers because in fact we are, in the y value, moving in the negative direction. Cool. So let's grab the ball and we'll bounce it. There. That's what we're looking for right there. Boom. Our change in y over change in time is 0 at that top, and this really shows it. And this is pretty right here. Is this not? Are you not impressed? Is this not lovely? We got our numbers kind of cruising up, decreasing, and we get to 0, and then we start getting these values cranking in, which is really pretty nice. And honestly, the first time I built this, I was like, oh, there it is. That's all I needed to see. Thinking back years ago to high school math. So I hope you really enjoy this one. I'll upload this and share it on Steam, and then I'll post that on Discord. And happy parabolas. All right, signing off.